Welcome, ladies and gentlemen, as we continue with our course, Computer Networks and Security. So, in our previous video, we looked at the various classifications that we have for computer networks, and we said these can be classified according to geographical area covered by the network, by the connectivity. We also talked about the classification by administration. And lastly, we said the classification can be by architecture. And in terms of architecture, we said the classification that are there, we have peer-to-peer networks, and we also have client-server architecture. So you realize the network classification that are listed there, personal area network, this can fit into what? Geographical classification, the same as LAN, the MAN, the wide area network, even the internet. Then if we are to look at architecture as well, you realize that the internet is mostly a client-server architecture. Same can go for the other networks. Then we look at admin-wise, how are the administration of these networks done? Probably the internet, it has main administrators. The lower area network, it might have a single administrator. The wide area network, it might have 2-3 administrators depending on the structure of the organization. The same goes what for the metropolitan area network. So today we want to continue and look at the data communication models that are in existence or that we use for our intent and purposes in this course. So you realize that there are many ways we can analyze data communication networks. And these data communication models provide us with a standardized way or a baseline for which we can analyze what computer networks. So these data communication models, where they are providing us with a standard way of looking at networks, we have to realize also and take cognizance of the fact that all networks provide what? The same basic function, which is what? To send and receive messages. It doesn't matter the hardware, it doesn't matter the architecture. The basic function of a network is to send and what? And receive messages. So we are going to look at 3 models. Not that these are the only models that are there, but for the requirements of our course, we're going to look at 3 models. So the models that we are going to look at under data communication models, we are going to look at the Shannon and Weaver communication model. Then we look at the open systems interconnection, popularly known as the OC reference model. Then we also look at the TCP/IP. So when we look at communication systems, no matter the architecture, no matter the software, the basic components that make up a communication system are the source, the channel, and the destination in its simplest form. The source can be you. The destination can be your friend receiving what? The message. The channel maybe can be the phone that you are using to communicate. The letter that you are using to what? To communicate. Or even the voice that you are using what? To communicate. This is what the basic what system of what? Or the basic components that make up any communication system. But when we are now going deeper and deeper as we dwell into networks and communication, we'll be adding layers upon each item. So you realize from the source, we might add what? Another item So that instead of it just being a source, we are now having what? The source and the data communication equipment. So the source now becomes what? The data terminal equipment. Then we have what? The data what? Communication equipment, the medium. At the other end, we also have a replication of what? Of what we have from the source. So as we can see from this diagram here, data communication systems are not that simple. The reason being, the language that you speak is not the same language that the communication medium understands or is able to carry. So whatever you speak has to be translated into a form that the communication medium can understand. And this is the role of the data communication equipment, to convert whatever language you speak into what a language the medium understands, and vice versa. So as we go along, you will be able to identify the various data communication equipments that are there and understand how they function or operate. For example, here we can have a modem, we can have routers, etc. Let's look at the Shannon Weaver modem. So this is more of an extension or expansion of this model here. So this model was created by Shannon Weaver in 1947, and it added certain elements that were not there in the basic model that we talked about earlier. So you realize here we have the sender, the transmitter, which is the responsible for encoding the message into a form that the channel understands. Then the decoder, which decodes back to the original form so that the destination or the receiver can understand the message. And one thing that the Shannon Weaver is, that is not the element of feedback. Feedback allows or enables the sender to confirm that his message is what has been received or has been understood. So this model, as it appears, it looks like it's just a simple model that is talking to the basic communication, like you are talking to your father and mother, you are talking to your brother over the phone. You know those sounds that you make when someone is talking, giving feedback that you are understanding or you are hearing what one is saying. That's in its simplest form. But you realize as we look at communication systems, the things that are there, we now expand them. The element of noise. We are communicating over a network. Where is the noise? Which one is the noise? How is the noise created? Encoding. We are communicating over a network, on a local area network, with someone probably on another network somewhere. How is this message being transmitted? How is it being encoded? What kind of a channel is it being used? Is it wireless? Is it wired? So you realize when you are now going deeper into this model, it will cease from being just a simple model, but into a detailed communication model. You talk of protocols. Which protocols are used to encode and decode? Which protocols are used to transmit? So you can just extrapolate this model and put it on a LAN. Then you will be able to identify the various components that are there. So this is the first communication model that we look at. Like I said, you might think that no, this is relevant to communication that we did in communication, computers, and drawing. But this is very much relevant to this subject. computer networks, and what? And security. Now we want to look at the element of effective communication. After looking at the elements of effective communication, we'll come back again and look at the other two modules that we said we are going to what to look at. So effective communication is a process of exchanging ideas, thoughts, knowledge, and information with the intention being what? Getting the communicator and the receiver of the communication filled or satisfied that communication is what has taken place. So simply put, effective communication, you can say that it is the presentation of views or information by the sender in a way that what the receiver understood or understands. So if you send or communicate a message and it is not understood, it means you have not communicated what effectively. The same we can interpret it on a network. If you send a message on a network, let's say you send an email, then it arrives at the receiver's inbox, or it gets lost along the way, or when it arrives at the receiver's inbox, the message is not as it was sent, or some characters have been lost along the way. It means there's no effective communication there. So some of the characteristics of effective communication include what? Clarity of the message, correctness of the message, completeness of the message, reliability of the message, and what? And the communication channel as well. Then what? There's also need for courtesy as well. Considering what? The views, thoughts, and opinions, or even feelings of what? Of the receiver as well, as you package your message. So if you are going to look at this and put it on a communication network, we have protocols that govern what? These various aspects. We ensure that when you communicate over a network, the meaning of a message is not lost, or the correctness of the message is not lost as the message is being transmitted. So we'll look at the various aspects of communication networks that enables us to have effective communication. So I think these we are familiar with, or we have covered in CDC, so we won't labor much on this significance or what, or benefits of effective communication. Then we also look at what? At the barriers to effective communication. Probably what I might just touch on here is the physical barriers in relationship to networking equipment. So as you can see, we are going to extrapolate this is there in communication. Then we bring them to computer networks, physical barriers. I talk about distance, the medium being used. So as you can see, while these are in communication, as in communication in general, these can also be brought to computer networks. So let's move on and look at the next segment that we want to look at, which is signals. What is a signal? No understanding, or from what you have learned and what you have read, how would you define a signal? So as we try to understand or define what a signal is, we have to understand that when we communicate, especially over networks, whenever you send information over a network, the form that you as the transmitter dispatches the information is not the same form that what the information will be transmitted over a network. So this is where the element of signal comes in. And we have two types of signals that we are going to look at, which are analog and digital signals. And these signals are able to transmit information in be it data, voice, pictures, and so on. All these kinds of information can be converted into any of these two types of signals. So simply put, a signal is the physical representation of information over a medium where the signal will be transmitted. And these signals are transmitted in different ways. So the ways in which we transmit these signals is either we transmit them digitally, or we transmit them in an analog way. So digital signals are represented graphically as shown in this diagram, where we have these squares and these gaps between squares. So this will represent a 1, a 0, a 1, a 0. In fact, digital signals in their simplest forms, they are either a 1 or a 0, which electronically can be represented by alternating voltages, being a high and a low voltages, representing being a high and a low voltage to represent the signals. So I won't dwell much into the aspect of signals, as this is a subject on its own that can be studied in detail. We'll just look at the simplified form of a signal, where we say the one of the simplified form of a digital signal, where we say the 1 or a 0, which can be represented by alternating voltages with either a high and a low, a on or an off. So this is the diagrammatic representation of a signal. Let's look at the analog signal. This refers to something that is continuous, and it is represented by by fluctuations in voltages. So this is the diagrammatic representation of an analog signal. So the difference between an analog and a digital signal, as you can see between these two diagrams, this one is fluctuations in variations in electric current, which is either an on and off, a high and a low. While this one is these are fluctuations in voltages, but it's continuous. So when we have these signals, how do they travel from one point to the other? Usually the way a signal travels is determined by by the transmission medium that is being used. And in terms of transmission medium, it can be categorized into 3 classes, which are conductive metal or conductive transmission media. Then we have the transparent transmission media, or the transparent glass strand, popularly known as optic fiber. Then we have the wireless communication media. So in terms of the conductive transmission media, we have copper wires, coaxial cables, twisted pairs. Then for the transparent glass, we have optic fiber, which uses light waves Then for the wireless, we have satellites, repeaters and boosters, which are used to what to broadcast and send messages over wireless channels using specified frequencies. And one key thing that wireless signals use is electromagnetic waves. So for your device to be able to receive a wireless signal, it means it's supposed to be able to receive these electromagnetic waves. For interest sake, we may just want to look at some of the advantages of the two types of signals that we have talked about. Analog signals, I think these are some of the advantages that I have listed there. Then in terms of digital signals, these are some of the advantages that we have. And it is important to note that digital signals have really changed the communication space in terms of how they are manipulated, how they are transmitted, how they are stored. Even the data processing, you can do it randomly as compared to analog signal. Even the storage locations as well can be manipulated randomly for digital signal as compared to analog signal. So I expect you to read further on these, the advantages and disadvantages of analog and digital signals. So we won't labor much on this. I expect you to take some time and just flip through these slides so that you get to appreciate the advantages and disadvantages of analog signal and digital signal. Now that we have talked about signals, what challenges can we face with communication systems or when you are communicating? You are communicating with someone in the UK over a phone, or you are sending an email to someone in Blawayo. What do you think are the challenges that we face with communication systems? One thing we have to appreciate is that as we are sending our messages or our communications over communication networks, we have to understand that they are not perfect. The transmission mediums, the systems that we use, they are not perfect. And this imperfection affects the signal quality, or some might refer to it as impairment of signals. Which means when you dispatch a signal from point A to point B, it will lose some characteristics or some quality or some value as it moves in the transmission media. So these are the challenges that we are referring to, that communication systems face. So look at about 2 or 3, then I expect you to write some notes on the other 2. Let's look at the first one, attenuation. When we talk about attenuation, we are talking about the loss of strength in a signal as it moves from point A to point B. A very good example is when you use your voice. Let's say you want to shout something to someone who is 50 meters away from you. When you shout, the person who is closest to you will get your message very clearly. But as the distance increases, your voice begins to lose strength. This is the same concept when we transmit messages over what? Over communication medium. So this is just a demonstration of what? Of that. You can see that the signal strength at the start here is quite what? Compressed and shows that there is high strength. But here it's what? It's now losing strength. And after it's amplified, again you can see that it has gained what? Some strength. And this attenuation is very popular in what? In copper transmissions in coaxial cable. That's why they have to use what? Repeaters and amplifier, that after some certain distance it is amplified so that at least it's able to reach its intended destination. Then we have noise. A very good example of noise in a transmission for those who use landlines or who use landlines. At times you get these funny noises when you are using a landline. And I think even in cell phones, sometimes you also get this funny interference where you have these funny sounds that you overhear. This is the noise that what we are talking about. So there are several types of noises which include crosstalk. Like if you use landlines before, you will overhear conversations of other people who are using a different landline, which is crosstalk. Then we have thermal noise, impulse noise, and these noises, some of them are caused by electrical currents or the functioning of what of the devices at various points in the network. This is just a demonstration, just trying to show the effects of noise on what? On the signal. You can see here that the intensity of the signal has changed because of what? Of noise in the transmission medium. And even as it arrives at the destination, you can see that the signal is no longer the same as it was from what? From the start here, because of what? Of the effects of noise that came into play as the message was being transmitted. So I want you to go and read and make some notes on jitter, distortion. Again, I think the example that I gave here just demonstrates what? A signal that has been distorted by what? By noise. So that it loses what? The 100% originality that he had when it was transmitted. As you can see here, there's one element that is what? Distorting what? Signal here. So if a signal changes its form or shape as it is being transmitted, we refer to as distortion. And this distortion is usually seen in what? In composite signals that use different frequencies when they are being transmitted. Let's just see the diagram of what? For distortion. As you can see at the sender here, look at the wavelength and the structure of the wavelength. Say these are composite what? Signal. Now look at the final signal. There's been what? Some distortion. Delay. Propagation delay is the amount of time it takes to hit the signal, travel what? So it's the time it takes for the head of the signal to travel from the sender to the receiver. I think this is very common if you've ever received calls. Let's say here in Zimbabwe, you get a call from someone in the UK or in Australia. You realize when you talk, there's that gap time that you have to wait for someone for you to hear completely what someone is saying. That is what the delay. Or even when you're live streaming, sometimes you realize that someone who's watching a live stream and someone who's watching on a television, you're watching the same football match, but you might realize that the images are slightly different. The reason that force or the cause of that is what is the delay in what in the movement of the signal on different channels. And usually it also causes some distortion in what in the signal. So I expect you to go and write notes on the last one. So I said I'll give you 3 which I've done. So you write notes on what on distortion, then you read and write notes on what on jitter. For my part, I've talked about attenuation, noise, and delay. Now let's go back and look at what the other model that I said we are going to look at, the OC reference model. But before we proceed to look at that, we'll just take some time to reflect. Thank you very much for the time you've taken to listen to this.